Hey guys, welcome to question MM349 of the Maths Methods Fortify study guide. So this question gives us two graphs, f of x equals 4 take x squared and g of x equals 2x. They're shown on the diagram below. Part A tells us to find the coordinates of the x and y intercepts of f of x. So pretty straightforward. We just need to make sure that we answer this correctly and don't make any errors. So in order to find our x and y intercepts, for our y-intercept, we let x equal 0, so f of 0 is equal to 4 minus 0, which is 4. So our y-intercept has a coordinate of 0, 4, and for our x-intercepts, we let y equal 0. So 0 is equal to 4 minus x squared equals 4, x equals plus minus 2. So therefore our x-intercepts have coordinates of 2, 0, and negative 2, 0. Pretty straightforward question. It's just a 1 mark question, as it should be, but that's it. Let's move on to part B. Now part B is a 2 mark question, or part BI I should say. 2 marks. And says find the coordinates of points P and Q, the points of intersection between g of x and f of x. Awesome. So as always guys, with points of intersection we are letting g of x equal f of x. That's going to allow us to find the x values that they're intersecting at. So g of x is 2x, f of x is 4 minus x squared. So just getting everything onto one side, so we get a quadratic kind of formula. We get 0 equals x squared plus 2x minus 4. Awesome. Now, there's multiple ways we can do this. We can do this on our CAS, which I would recommend doing. So according to CAS, x is equal to root 5 take 1 and negative root 5 take 1. Awesome. So from here, that's our first mark, but we also need to make sure that we include our y values, right? Because we're looking for the coordinates, not just the x values. So from here, we can say that g of root 5 minus 1 is equal to 2 times root 5 minus 1, and g of negative root 5 minus 1 is equal to 2 times negative root 5 minus 1. Awesome. Which means that our p value, or our p coordinate, is the lower value. So our negative root 5 minus 1 to negative root 5 minus 1. And our q value is our positive one. So root 5 take 1 to root 5 take 1. And that's our second and final mark. So that's it for part BI. Let's move on to part BII. Part BII is fairly straightforward. It's just a 1 mark question, so we can actually just write down the answer without having to show any working essentially. So it asks us to find the area of the shaded region above. So just this area here. So because it's a 1 mark, all we're going to do is just say area is equal to our integral from p to q of the top function, which is f of x, minus the bottom function, which is g of x, dx. So what we're going to get is, we found that our lower bound was negative root 5 minus 1, upper bound was root 5 minus 1, f of x is 4 take x squared, and our lower bound is g of x, which is 2x dx. We can simply plug this into our calculator, and what we get is 20 root 5 over 3 units squared. That's our first and only mark for this question. All we really need to make sure we do is that we keep it in exact form, because it didn't tell us to find decimal places, right? So 20 root 5 on 3 is our exact form, and that's it. So that's our first and final mark for that part. Let's move on to part C. So part C is a little different. It introduces a new kind of graph. It says the graph of y equals h of x is drawn on an axis with the graph of y equals f of x, where h of x equals g of x plus a, and a is greater than 0. Okay, so that's going to be important later. Find in terms of x find in terms of a the coordinates of x, the point of intersection between h of x and the x-axis. Awesome. So if we know that h of x is equal to g of x plus a, and g of x is equal to 2x, that means that h of x equals 2x plus a, right? That's all good. If we're looking for the point of intersection between the x-axis, we're looking for the x-intercept, right? Which means that our y value is going to be 0. So 0 equals 2x plus a. And we're looking for our x value in terms of a, which means we get negative a equals 2x. So therefore x equals negative a over 2. So our x coordinate occurs at negative a on 2, 0. That's our first and only mark for part CI. Let's move on to part CII. Part CII is a 2-mark question. It says, find the coordinates of R and S, the points of intersection between f of x and h of x. So, from here, we know that, as always, when we're finding points of intersection, we let f of x equal h of x. And we can say that f of x is 2x, f of x is 4 take x squared, and h of x is 2x plus a. Right, because we're looking for this in terms of a, the coordinates of R and S in terms of a. All we want to do is just get everything onto one side, as we have before in previous parts. So we end up with 0 equals x squared plus 2x plus a minus 4. And the only way we can really solve this is by using the quadratic formula. Okay, so we know that x is equal to negative b plus minus square root of b squared minus 4ac over 2a. Where this is our A, this is our B, oops, sorry, that's not our A is our 1 out the front here, A, B, and this whole thing here is our C. So, negative B is negative 2, plus minus the square root of 2 squared minus 4 times A, which is 1, times C, which is A take 4. All over 2A, which is just 2, okay? Now, this comes out to be x equals negative 1 plus minus the square root of 5 minus a. That's our first mark. Okay, so finding those x values is the first mark. But we're not done. We need our coordinates, right? So we're looking for R and S, the points of intersection, the coordinates. So h of negative 1 plus root 5 take a, because that's our x value, is equal to 2 times that, 2 times negative 1 plus root 5 minus a, and then plus a, right? Because it's 2x plus a is our h of x. So h of x equals 2x plus a. Awesome. Sweet. And then our h of negative 1 minus root 5 take a is equal to 2 outside of negative 1 minus root 5 take a plus a. Sweet. So that means that r is equal to negative 1 take root 5 take a to negative root 5 take a take 1 plus a. S is negative 1 plus root 5 take a to root 5 take a take 1 plus a. Awesome. This bit here is our second and final mark for part II. This can be a bit confusing, and it might feel like you've kind of done this before with the previous part, but the reason we're doing this is to be able to work out the next couple of questions. So that's it for part CII. Let's move on to part D. Part D is a 3-mark question and is a little bit more complex. So, 3 marks. And what it says is, find the value of A for which the shaded regions A1 and A2 are equal, corrected 2 decimal places. Awesome. So A1 is this first area here, A2 is this second area here, and we're going to need to make these equal to each other. So let's just deal with A1 first, and then we can come back to A2. So we'll deal with these separately and then solve them. So our first area is we're going to need to break this itself up into 2, right? Because we've got this kind of crossover point here, there. So this first section here is the area from this x-intercept, which we found to be negative 2, to our point at x, which was negative a on 2, under f of x, right? So the area from negative 2 to negative a on 2 of f of x dx, and then plus So this section here now will be from x, which is negative a on 2, up to s, right? So to this point of point of intersection here, which has an x value of 5 take a minus 1 of f of x minus h of x, right? Because we're finding the area between these two graphs now. The top one is f of x, bottom one is h of x, so f of x minus h of x there. Now, let's just input our values here, or input our formulas. F of x is 4 take x squared, x, plus negative a on 2 root 5 take a minus 1. Awesome. Of f of x, which is 4 take x squared again, minus h of x, which is 2x plus a dx. Awesome. So what this spits out is a1 is equal to 2 outside of 5 minus a 3 on 2 over 3 minus a squared over 4 plus a plus 2 over 3. And that's our first mark. Okay, so we've got our first area in terms of a, and now we want to get our second area in terms of a, and then solve those for like little a. Cool. Yeah, I'll just keep going down here. So now we can deal with that a2. Now a2 is a little bit more straightforward. So we still need to split this into 2 because we've got this point of intersection here. But this a2 is this first area here, which is the area under h of x from x to s. Okay, so from x, which is negative a on 2, to s, which is root 5 take a take 1, of h of x, which is 2x plus a dx. And then we're adding this area here, which is from s to the other intercept, which is 2. So from s, which is root 5 take a take 1, up to 2, and then of f of x, which is 4 take x squared dx. Awesome. So now what this spits out is a2 equals 2a over 3 take 10 over 3 outside of 5 take a, and then plus a squared on 4 take a plus 10. That's our second mark, okay? So now we've got a1 and a2 in terms of a, and if these two areas must be equal, like if we want to make them equal to each other, we need to equate them, right? And then solve for a. So what we do is we take this formula here, this formula here, and we solve them in CAS. So we say a1 equals a2, and then we solve for a. So solve this for a, and what this spits out is a equals negative 9.54 and a equals 1.88. Now the question tells us that a must be greater than 0, so therefore a is equal to 1.88. This is our third and final mark for part D. I know it's very, very confusing, but all you need to make sure of is that you have all the correct terminals in your integrations. Make sure that you let the areas equal each other and then solve it in CAS and you'll get this. That's it for part D. Let's move on to part E. Part E is a 2-mark question and asks us to find the range of values of A for which the equation h of x equals f of x has 2 solutions. Alrighty, awesome. So E is 2 marks and we're looking for h of x equals f of x has 2 solutions, okay? Now, if we have h of x equals f of x, that means that we've got 2x plus a equals 4 minus x squared. Now, I'm just going to get all this onto one side, so we end up with 0 equals x squared plus 2x plus a minus 4. And the thing we need to notice about this is a quadratic, okay? And if a quadratic has 2 solutions for 0, that means that our discriminant is greater than 0, okay? So discriminant is greater than 0. Now, discriminant is equal to b squared minus 4ac, which means that has to be greater than 0. Now, our b is this, our a is our 1 out the front here, and our c is a minus 4. So what we get is b squared, which is 2 squared, minus 4 times a, which is 1, times a minus 4. And that is greater than 0. So then from here, we can say that this is 4 minus 4 times a minus 4, which is greater than 0. And this gives us 4 minus 4a plus 16, which is greater than 0. And then this gives us 20 minus 4a is greater than 0. Now we can simply just keep solving this for a. What we end up with is, I'll just rewrite this, 20 take 4a is greater than 0. And then from here we can say that 20 is greater than 4a. So 5 is greater than a, which means that, I'm just going to swap them over, a is less than 5. Awesome. Now actually, first of all, when we sub in our discriminant, that's when we get our first mark. So when we say, 2 squared minus 4 times 1 times a minus 4 is greater than 0, that's our first mark, right there. This is a 2-mark question. We're not done yet because the question says that a has to be greater than 0, right? So we need to find the intersection between these two things here, which means that a is greater than 0, but less than 5, which is our final answer. So this is our second and final mark for part E. That wraps up MM349. Guys, if you have any questions, as always, please hit me up in the comments below. But otherwise, thank you very much for watching, and I'll see you in the next video.